Space, the final frontier. These are the voyages of the Starship Enterprise. Its continuing mission to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no one has gone before.
In the Star Trek series, warp speed refers to a theoretical propulsion system that allows starships to travel faster than the speed of light. The concept of warp speed is central to the Star Trek universe, as it enables the crew of the Starship Enterprise to explore distant planets and galaxies in a reasonable amount of time. In the Star Trek canon, the warp drive works by manipulating space-time itself. It generates a subspace bubble around the starship, which allows it to travel at faster than light speeds by contracting the space in front of the ship and expanding the space behind it. This creates a warp field that effectively moves the ship through space without violating the laws of physics that prohibit faster than light travel. Warp speed is measured in warp factors, with each factor representing a multiple of the speed of light. For example, warp factor 1 is the speed of light, while warp factor 2 is 8 times the speed of light, and so on. According to Star Trek lore, the maximum sustainable speed for a starship is warp factor 9.9, which is over 2,000 times the speed of light. To understand how a warp drive might work, it is helpful to first understand some of the basic principles of Einstein's theory of relativity, which describes the relationship between space, time, and the speed of light. According to this theory, the speed of light is the absolute speed limit in the universe. This means that it is impossible for any object to travel through space faster than the speed of light. One way that scientists have proposed to get around this speed limit is by warping the space-time fabric itself. The idea is that a spacecraft equipped with a warp drive could create a warp bubble around itself, which would distort the space-time in front of it and allow the spacecraft to travel at speeds faster than the speed of light without actually breaking the speed limit. One example of warp drive method is Alcubierre drive. The Alcubierre drive, also known as the Alcubierre metric or the warp drive, is a theoretical solution to the equations of general relativity that could allow for faster than light travel. It was first proposed in 1994 by Mexican physicist Miguel Alcubierre. The basic idea of the Alcubierre drive is to use the properties of spacetime to create a region of contracted space in front of a spacecraft and expanded space behind it, effectively creating a wave that the spacecraft can ride. This would allow the spacecraft to travel at speeds greater than that of light without actually breaking the speed limit, because it would not be moving through space in the traditional sense. Instead, it would be riding a wave of spacetime itself. While the Alcubierre drive is an interesting theoretical solution, it is not without its problems. One major issue is that it would require a tremendous amount of energy to create and maintain the necessary warping of spacetime. It is not clear if this amount of energy is physically possible to obtain or manipulate. In addition, the effects of such a warp bubble on the objects inside it and on the surrounding spacetime are not fully understood, and there may be unforeseen consequences of its use. As a result, the feasibility of the Alcubierre drive remains a topic of scientific debate and research. Another proposed method for creating a warp drive is the Krasnikov tube, which involves using a network of interconnected wormholes to create a shortcut through spacetime. The idea is that a spacecraft could enter one end of a wormhole, travel through it, and emerge from the other end, effectively jumping across large distances in a very short amount of time. The concept of a Krasnikov tube was first proposed in the 1990s by Russian physicist Sergei Krasnikov. It is similar to the idea of the Alcubierre drive, which also involves manipulating spacetime to allow for faster-than-light travel. However, The Krasnikov tube uses wormholes rather than a warp bubble to achieve this effect. The tube is a distortion of spacetime that can be intentionally created using hypothetical technology in the wake of travel near the speed of light. The Krasnikov tube allows for a return trip that takes travelers back to the time right after they left. Experiencing the effect requires that the traveler race along the tube at speeds close to that of light. Krasnikov argues that despite the time machine-like aspects of his metric, it cannot violate the law of causality, that a cause must always precede its effects in all coordinate systems and along all spacetime paths, because all points along the round-trip path of the spaceship always have an ordered time-like separation interval. This means, for example, that a light beam message sent along a Krasnikov tube cannot be used for back-in-time signaling. One major issue with the Krasnikov tube is that it relies on the existence of stable, traversable wormholes, which have not been observed in the universe and may not be possible according to our current understanding of physics. In addition, even if such wormholes did exist, it is not clear how they could be used to create a safe and stable means of transportation. As a result, the feasibility of the Krasnikov tube as a method of faster-than-light travel remains highly speculative. The idea of a warp drive as a future transportation system is highly speculative and currently not possible with our current level of technology. As a result, the feasibility of a warp drive as a practical means of transportation is still a topic of scientific debate and research. It is not yet clear if it will ever be possible to develop a warp drive or if it will remain a purely theoretical concept.